Hello and welcome to Cambridge Advanced Level Mathematics Calm, where we really calm down the mathematics for you. In today's lesson, we have got a question from paper 1 of 2023, question number 2, and it reads as follows. Find the first three terms in the expansion of 2 plus 3x to the power 4. Question B. Find the first three terms in the expansion of 1 minus 2x to the power 5. Question C. Hence, find the coefficient of x squared in 2 plus 3x to the power 4 multiplied by 1 minus 2x to the power 5. And I've put some little numbers in blue there against each question. These are the marks that were allocated by Cambridge to each part of the question. Now, clearly, this is a question which involves the binomial theorem. What is the binomial theorem? The binomial theorem is a formula that enables us to expand a binomial to any power. A binomial is any expression in two terms, with two terms like x plus 3 or 1 minus 2x raised to the power 4 or p plus y raised to the power 20. All these are binomial expressions. Now I'm going to put it up here, the binomial theorem for you, and then we can look at it term by term, examine it, understand it, before we can use it to tackle our problem on the board. Now, supposing we have an expression like a plus x raised to the power n. The binomial theorem says this is equal to a to the power n plus n a to the power n minus 2 x plus n brackets n minus 1 a to the power n minus 2 x squared, all this over 2 factorial. I'm running out of board, I'm coming over here now, plus n brackets n minus 1 n minus 2 a to the power n minus 3 x to the power 3, all this over 3 factorial. Plus, 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 it gets to a general term, n brackets n minus 1, n minus 2, n minus 3, up to n minus r plus 1, brackets x let me push it to this side a little bit. It's about to be squashed. So it's plus, 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 n brackets n minus 1. See if we can get a pen that right. N minus 1, n minus 2, n minus 3, all the way up to n minus r plus 1, a to the power n minus r, x to the power r, all this divided by r factorial. And it goes on and on and on until it gets to the last term, which is x to the power n. That is the binomial theorem. Right. We should notice a few things here. In every term, the power of a, the power to which a is raised, plus the power to which x is raised, always equals n. Here x is raised to the power 0. A is raised to the power n. Here a is raised, sorry, this is a 1. Sorry, supposed to be 1 here, sorry. Here a is raised to the power n minus 1, x is raised to the power 1. So n minus 1 plus 1 gives you n. Here a is raised to the power n minus 2. X is raised to the power 2. So n minus 2 plus 2 is always giving you n. Here, a is raised to the power n minus r. X is raised to the power r. N minus r plus r is always giving you a. Now, this is called the first term. This is called the second term. This is called the third term. This is important because sometimes the examiner might ask you to give you a certain term, let's say the fourth term or the fifth term. Remember, the third term is the one where x is raised to the power 2. The second term is the one where x is raised to the power 1. And the rth term is one where x is raised to the power r minus 1. So this term here, the one where x is raised to the power r, is the rth plus 1 term. Because the rth term is the one where x is raised to the power r minus 1. This is called a general term. It's a general term. I don't like this one. It seems like it splashes ink all over the place. So there's a general. There should be a better one, sure. Okay. This one. Okay. There's a general. Oh, it's worse. It's a general term, anyway. It's a general term. The other thing that we need to look at is there is here our 2 factorial or 3 factorial or r factorial and so forth. What does factorial mean? Factorial means if you have 5 factorial, it means 5 times 4 times 3 times 2 times 1. 3 factorial means, this is 5 times 4, 20 times 3, 60 times 2, which is equal to 120. 3 factorial is equal to 3 times 2 times 1, which of course is equal to 6. 7 factorial is equal to 7 times 6 times 5 times 4 times 3 times 2 times 1. I'll need a calculator for this. My calculator is a sharp calculator. It's got a factorial function. So I want 7 factorial. I press my 7 there. I look for the factorial function, its second function, factorial. There you are. It gives me 5040. So 7 factorial is equal to 5040. What about r factorial? R factorial means r factorial is equal to r brackets r minus 1 brackets r minus 2 brackets r minus 3 all the way until it gets to 3 times 2 times 1. For example, where r was actually 7 up here, there is your 7 there. 6 would be 7 minus 1. Your 5 would be 7 minus 2. Your 4 would be 7 minus 3. Your 2 there would have been 3 r minus 4 there, which gives you 7 minus 4. That gives you that 3, etc., until you get to 3 times 2 times 1. So that's factorial notation there. What else? Okay, I think we are ready to tackle our examination question on the board. let's start with the first part, A. Let me just allow me to get rid of this. Right, the first part says find the first three terms in the expansion of 2 plus 3x to the power 4. Once again, we are only going to expand up to term number 1, term number 2, term number 3. We're not going up all the way up to x cubed and x to the power 4 and so forth and so on. So we have our 2 plus 3x raised to the power 4. What is our a? Our a in this case is 2. What is our x? 3x is taking the place of x. So we are going to expand it around 3x. So let's get cracking. This is equal to, the first term, of course, is your a to the power 9, which is 2 raised to the power 4, because n is 4. Second term is n, which is 4, multiplied by our a, which is 2, raised to the power 4 minus 1, which is 3. And we bring down our 3x there. It comes now. Okay? The third term, which is the final one we are interested in, is we have here, which is your x squared term. It is 4 times 4 minus 1 times 3 multiplied by 2 now raised to the power 4 minus 2, which is 2, and our 3x raised to the power 2. And all this over 2 factorial. 2 factorial, of course, is just 2. So now let's go ahead and simplify this thing. 2 to the power 4 is 16. Then here we have an 8. 2 to the power 3 is 8. 8 times 4 is 32. 32 times 3, it's a 96. X. Here we have 3 times 4, which is 12. 12 times, this gives us a 4. 12 times 4 is 48. 48 times 3 times 3, which is 9. 48 times 9, 48 times 9, which is 432, divided by 2 factorial, which is 216. So it's plus 216x squared. We will need this result in part C. So let's tuck it away somewhere. I'll put it here. It's 16 plus 96x plus 216x squared. Okay, so I'm sure we can get rid of this. Get rid of this here. Right. Question B. Find the first 3 terms in the expansion of 1 minus 2x to the power 5. Once again, we have this. It's 1 minus 2x to the power 5. Our n here is 5. Our a is 1. And our minus 2x takes the place of x. Expanding as before, we have 1 to the power 5 is 1, of course, plus n is 5, multiplied by 1 to the power 4 is just 1. And then we introduce our minus 2x, of course, 2x raised to the power 1. The next term is that's 5 times 4, so it's 5 brackets 4, which is n minus 1, multiplied by 1 to the power 3, still 1, and then this one raised to the power 2x raised to the power 2. All this, of course, over 2 factorial. 2 factorial. Let's simplify. This is equal to 1 minus 10x. Here we've got 5 times 4, 20. 20 times 4, which is 2 squared there, is 80. 80 divided by 2 factorial is 40. It's a plus because that one is squared. So we have a 40x squared. Let's just check this again. 5 times 4, 20. 20 times 2 times 2, which is 40. 80. 80 divided by 2 is 40. So here's another result. This one gave us 1 minus 10x plus 40x squared. Now, in part C, they want us to expand this, multiply this and that, and then give them the term in x squared. We have already done this. We've done that. All we need is to multiply this and that together and identify the term in x squared. So starting with that one there, we have a 16 plus 96x plus 216x squared, close our bracket, multiplied by 1 minus 10x plus 40x squared, all the way there. Now, we want the coefficient of x squared. If I multiply, when I multiply this out, if I multiply 16 by a 1, it doesn't give me my x squared. So I'm not interested in that. If I multiply a 16 by a minus 10x, it gives me 160x. I'm not interested in that. It's not x squared. If I multiply a 16 by a 40x squared, I get something. Let me see. What is 40 times 16? Okay, so this one gives me a 640x squared. So I get a 640x squared. I'm interested in that. Okay, so I'm done with the 16. Let's deal with 96x. If I multiply a 96 by this one, it gives me a 96. I'm not interested. When I multiply a 96x multiplied by a minus 10x, it gives me an x squared. So this interests me, which is equal to minus 960x squared. An x and an x gives me an x squared there. Okay, but beyond that, 96x times 40x squared, that gives me an x cubed. I am not interested. So beyond that, I stop. Then I come to 216. If I multiply a 216 by 1, a 216x squared by 1, it does give me an x squared. It actually gives me a 216x squared. If I try to multiply this thing beyond this, it starts giving me an x cubed, and I'm not interested because this times that is x cubed. That will give me an x to the power 4, which I'm not interested in. So I've collected all the terms that have x squared, and we can add them up. So let's see what this comes up to. So 640 minus 960, which is that, then plus 216, which is that. So I'm getting here a minus, which is equal to a minus 104. The examiner is just interested in the coefficient of x. So that's the number there, minus 104. Okay? So that is the binomial theorem for you. Look at that. This is, the whole paper was worth 75 marks, and this adds up to 6. 6 over 75, 6 divided by 75 is equal to that, multiplied by 100, which is 8%. 80% is a lot of marks. Thank you very much.